All right, so guess what? More multi-step factoring. And I know it might seem like we're beating this into you, but like I said, this is the most important thing that you can be. If you can be so solid on this when you get out of here, this is the goal. So again, our goals here. So common factor, so GCF, this is always the first thing that you want to try, okay? Two terms, we could have difference of squares, or sum and difference of cubes. Three terms, so this is trial and error, or guess and check. And then the last one is grouping, and grouping is going to be the next lesson, so you won't see grouping here today, but that's okay. We're going to do all of these. So in the first part, in 4.3a, we were just looking at GCF, and then from GCF, difference of squares. Now we're going to do all of these different ones all together. All right, so what I'm going to do, I'm going to pop around a little bit, and then I'm going to have you go back and do some of these too, and then I'll talk through the answers. So step one, GCF. So I see 10, 25, and 15. So I know I can pull out a 5. So 5 times what? 5 times 2, and I still have my x squared. I go to the middle term, 5 times 5, and I still have an x. And I go to the last term, 5 times 3 gives me plus 15. Now, we can't assume that we're done, right? We can't assume we're done because this is a trinomial. This is 3 terms. I might be able to do trial and error to factor this even more. So I have 1 and 2 and 1 and 3. Those are my 2 factors. I know this is addition and this is subtraction, so I need negative, negative. So if I have 3 times 1 is 3, plus 1 times 2 is 5. So I can get 5 out of this. So I know it's going to factor. I'm going to have 2x, and I'm going to have 1x, and I know that this is going to be a 3, and this is going to be a 2, and they have to be the same sign. So now I'm going to check, and I'm going to have negative 3x. Oh, hold on, what did I do wrong? Oh, this should be a 1. Sorry, this should be a 1. So negative 3x minus 2, which is negative 5x, which is what I have. So this is my answer. See, it's always such a good idea to go back and do this check, because I would have made that mistake. Okay, let's go on to this one. All right, we got a lot happening here. This is 10, this is 23, and this is 12. So because this is an odd number, I can't pull anything out of that. I can't pull a number out of this. If this was an even number, I know for sure I could pull out a 2, but 23 is prime, so I can't pull anything out. But I have x, and I have an x, and I have an x. So I know I can bring this x out. And what's left is 10x squared plus 23x plus 12. Okay, so let me look at this. I'm going to look at just my 2 middle terms first. So 2 and 5. And 3 and 4. And my goal here is to get 23. So 5 times 4 is 20. 2 times 3 is 6. So that doesn't work. So let me look at the other one. I have 5 times 3, which is 15, and then 2 times 4, which is 8. So 15 plus 8 is 23. So that works. So I have my x. Right, so if I want this to be 23, I'm going to have 15 and 8. And this is positive, so I know I'm adding. My middle term is positive. So when I check this, I have 15x plus 8x, and this gives me 23x, which is what I wanted. Okay, so when I look at this, I see a 20 and a 45. So the first thing that pops in my head is, okay, they're both divisible by 5. So I'm going to pull out a 5, and I see that I have x's in both terms, so I can pull out 1x. So what's left? 5 times 4 is 20. I pulled out 1x. I need 2 more. Okay, subtraction. 5 times 9 is 45, and I've already pulled out my x, so I'm done. So now what I need to look at is I've got 2 terms here. So So if I have two terms, this is a perfect square, this is a perfect square, and this is a difference. All right, next one. So I can't pull out anything because I have this odd number in the middle. So this is even, and this is even, this is odd. So I'm going to go straight to my factored form. So I have 1 and 8, and I have 2 and 4, and 1 and 2. Well, because this is positive, I know I'm going to have a negative negative, so I have to add, right? And so I see right away that this is going to give me 8 and 2, so I'm nowhere near. So I know that that factor is not going to work. So if I have 8 and 2 is 16, 16 plus 1 is 17. So I know that this is going to work. So I'm going to have x and 8x. This is going to give me 16, and this is 17, and I know that it's all negative. So now I'm going to look at it, and I have x minus 2 here, and then 8x minus 1. So there's nothing else I can do here, and there's nothing else I can do here. So this is one that's not multi-step. It's just a single step. All right, let's look at this last one down here, this last odd one. So 6, 9, and 60. So I know I can pull a 3 out of all of this. I can't pull out a 6 because of this 9. So I'm going to pull out a 3. I have an x, I have an x, I don't have an x. So I can't pull out an x. Why? 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 So what's left? 2x squared on the first term. What's left in the middle is 3x. I already took out my y. And what's left at the end is negative 20. Now, this one's a little busy, so I'm going to check it. If I distribute this in, I would have 6x squared y. So that one's good. I go to this one, I would have 9xy. That one's good. I go to this last one, I have negative 60y. That one's good. Always good to go back and check when they're a little harder like that. Okay, now I'm going to go look at the fact that this is a trinomial. Can I factor this? So 1 and 2. I'm going to start with my middle terms, which are 4 and 5. Okay, so I know that I'm going to have two opposite terms, so I have to subtract. So if I look at this, I would have 8, 2 times 4 is 8, minus 5, which is 3. So that's going to work. So I have 3y, and this gives me 2x and 1x. And I know that I'm going to have 5 and 4. So this is going to be 8 and 5. 8 has to be my positive. All right, so let's go check this. So I have negative 5x on the inside and positive 8x on the outside. When I add this up, I have 3x, which is what I wanted. So lots of stuff going on there. Okay, I'm going to go ahead and pause this. I want you to go work the even ones and then come back and I'll talk through them. All right, here we go. Let's go through this. So first one, this is not a perfect square. It's not 25 times 25. That happens often. It's not. You have to pull out the 2, and then you have a difference of squares on the inside. Okay? With this next one, you have to factor out a 3x, and then you'll use trial and error. Okay, this next one, the numbers here are a little bigger. I actually felt like I needed to go over here and do a check. So I factor out a 2x. So I have an 18x squared, a 9x, and a 2. And so when I go in and check this, I went in and did a little sidebar over here to make sure that it all added up. Okay, let's talk about number 8. So number 8, this is your correct answer. Okay, now I know I'm going to guess that some of you have this as your answer. 10x plus 10 and 10x minus 10. So my guess is that you might have this as your answer. Okay, now, if you remember back in the very first lesson, we say we always have to pull the GCF out first. Well, that's what I did. I pulled out the 100. I pulled out this GCF, and then I see that this is a difference of squares. Remember, this is the most commonly missed difference of squares because people forget that 1 is a difference of squares. But here's what happens. Remember, when we're factoring, we need to have our terms on the inside as low as possible. So really, what I have to do with this first term is pull out a 10, and I have x plus 1. And then with this term, I'm going to also pull out a 10, and I'm going to have x minus 1. So let me go through this again. So if you have 10x plus 10, I can factor out GCF, greatest common factor, out of 10, and I'm left with x plus 1. If I distribute this back in, I have 10x plus 10. So then I go to this term, and I pull out a 10, and I would have 10x minus 10. Well, what I have here is 10 and a 10, and everything here is multiplied together. So if I multiply 10 by 10, I get 100, and then I have x plus 1, x minus 1. This is a way harder way to do it. So always check for your GCF first. All right? And then the last one is just a simple difference of squares. I think, yep, that's it for that one.